Hello everyone, myself Orgodip and I am back again with another contest. In this video, the contest is Biweekly contest 114 and the contest is going to start in about 13 seconds. Let's refresh and check. Well, 6 seconds. So the contest is going to start. So let's hope for the best. We are recording. Let's go. Okay, so now the contest has started. 4 problems as usual. Saying the problems. Okay. Okay. So you are given an array names of positive index and an integer key in an operation. You can use the last element of the array and add it to your collection. Return the minimum number of operation needed to collect elements 1, 2 up till k. Alright. Okay. Cool. Int n equals to nums dot size. Cool. 4. I think I'm recording right. Cool. Okay, now let's just keep a vector of cool count of k plus 1 for int I equals to nums dot size minus 1 I will 0 comma I minus. Okay, int taken equals to 0, right? Collect elements 1 to k, right? If okay, so if nums of I greater than equals to 1, okay, so that's less than equals to k, if not of count of k taken plus not of count of nums of I taken plus count of okay nums of I equal to 1, right? Okay, answer equal to 0, right? If taken equal to k break plus return answer. I think that's it. I think should be 4, right? 4 is okay. Example test cases. Okay, 4 5 4. I think this is correct. Let's just submit our code here. Accepted. Cool. Let's now move to the second problem. You are given a 0 indexed array nums consisting of positive integers. There are 2 types of operations that you can apply on the array any number of times. Cool. Choose 2 elements with equal values and delete them from the array. Choose 3 elements with equal values and delete them from the array. Return the minimum number of operations required to make the array empty or -1 if it is not possible. Okay, 2 elements or 3 elements, right? Okay, so like 2, so like 2 so for the case 2 1 2 3 4, like, so you can apply that operation, okay, 2 number of times, right? Cool. So here 2 for the case 3 1 2 3 once, for the case 4 once 4, right? 2 2 2, so 3, but if the remainder is 1 then it is not possible, right? Okay, let's do it. Okay, so like, okay, map of int comma int mp for auto and x in nums mp of x plus for auto and x in mp int count equal to x dot second and answer equal to 0, return answer, right? Cool. Okay, if count percentage 3, if not of count percentage 3, answer plus equal to count by 3, else if count percentage 3 equal to 2, answer plus equals to count plus 1 by 3. So the remainders can be 0, 1, 2, right? So 0 and 2 case handled properly, but if the remainder is count percentage 3 by 2, right? Cool. Okay. But if the remainder is 1, so like the case 4, so like the case 4 we can do, okay, what is this? Okay, so like if the okay, so like 4, okay, 7, 10, 13, these are the cases, right? So for the case 4 we can just apply the operation 2 times. For the case 7 we can apply the operation 3 once and then apply the operation 2 times, right? Cool. Now for the case 10 we can apply the operation 2 times. Okay, got it. So like, okay, so like the base number is 4, right? The base number is 4 for the case 10. For the case 13 also we'll just keep subtracting 10, 7, 6, 10, 7, 4. Now after 4 you have to apply the operation 2 times, right? Else if count equal to 1, return -1, right? Return -1, answer plus equals to, okay, count -4 by 3 plus 2, right? Right, I think this is correct. Time is 4 minutes approx. Gone. 4 minus 1, this is correct, but I'm not sure. Let's just submit and be sure. Cool. Now coming to the third problem here, third and fourth, right? Fourth one seems to be a tree problem. Cool. You are given an array nums consisting of non-negative integers. We define the scores of subarray num cell to are such that as num cell and num cell. Okay, so the score of a subarray is the bitwise AND of all the elements in that subarray. Consider splitting the array into one or more subarrays such that the following conditions are satisfied. Each element of the array belongs to exactly one subarray. Cool. The sum of the scores of the subarrays is the minimum possible. Okay. So the maximum number of subarrays in a split, it's a DP, no, not DP. Cool. Okay, sum of the scores is the minimum possible, right? Let's split the sub in the following conditions: 1 0 2 0 1 2. So in this case, okay, so it's like I will do something like this, right? Okay. Okay, so if I just do the AND of all the elements, 1 0 0 1 and 0, yes, 1 and 0 0, right? Okay, so the minimum possible answer will always be 0, right? Okay. Got it, right? Okay, so the answer will always be, so the sum of the scores is the minimum, so the minimum possible score, so the minimum possible sum of scores is the AND of the whole array, right? Now the maximum number of arrays, right? Just first do this thing, and sum 0 for then we will think about it. Now sum, okay, so like sum should be, okay, and sum equal to nums of 0, right? Sum equal to sum and x, right? Cool, right? So now I've got the sum, which is required sum, right? Maximum number of servers in a split that satisfy the conditions above, right? Okay. Cool. So it is like, okay, like for the case 5713, right? So like we have to just make sure that each bit is counted only once, right? So like for the case 0120, right? 10, right? In this case each bit is counted on, so like we have to just make sure that each bit has to be counted only once. That's right. Cool. Seems like a good problem here. I don't know, or maybe I am stressing too much. Okay, not much submissions, maybe a good problem. You have to think. Cool. Okay, so it's basically like each element of the array, okay, sum of the scores of the sub arrays is the minimum possible, right? Okay, so basically like for, okay, so like the answer, so the output sum is the AND of the whole array. Got it? Now every bit which is included in the array, so like no bit which is just a second. So like every bit which is included in the something should be count. Okay, so like for the case 22222, the answer will be 5, because you can just split it. Cool. Also like the can we do it like something like this? So can I do it separately for each bit, like for the 5713 case, right? 5 is 101, 7 111, 101, 311, right? Okay, and the AND is actually 5. Okay, so in the AND, 1 is remaining, 0 1 0 1, this is not remaining. Okay, just a second. Just a second. No, not yet. 0 1 0 1, in this case it will be 0, and 1 1 it will also be 0, right? So in this case the best option to include it. Okay, I think that in all the other cases, okay, I think it's easy. I think it's pretty easy. Like it's something like this, like so, like if the bitwise AND of the whole array, if the bitwise AND of the whole array is greater than 0, then that means that at least one set bit is there which is set in all of the elements. So like if we split the array into some small sub arrays, let's say that into 2, then that particular set bit will be counted 2 times, right? That particular bit will be counted 2 times, so like it will increase our answer. So like if the got it. So if the bitwise AND is so like if the bitwise AND is what I say greater than 0, then in that case the answer will be 1. Otherwise the bitwise. Okay, so like just name it again, and beat, and I think this is it, though I'm pretty confident about this. If beat and okay, return 1, right? Yep, so like wonderful. Then in the other cases the beat and is 0, so like it's easy, like just form small sub arrays whose bitwise and becomes 0. For int I equal to 0, I less than nums dot size n equals to, I think I took a lot of time here, I should have found it pretty faster. But what to do? Int l equal to 0 for int r equal to l, r less than n comma r plus plus. Okay, so it's not possible something like this, right? Okay, so like minimum, okay, so now our problem becomes minimum split such that the bitwise AND of every subarray is 0, right? It can be possible, we cannot do it using the 2-pointer technique, right? Let's say that if my array is something like this, 0 2 2 2 2, right? 0 2 2 2 2, right? So now if I apply the 2-pointer technique here, I will just take 0 and the other 2s will go, cannot do anything, right? Or we can do something like this. Okay, so we can do something like this, like, so like just keep forming okay. It's like do it something like this. So that 2 2 2 2 2 2. So like firstly from the left, keep adding elements to our current considered subarray until the AND becomes 0, and once the AND becomes 0, we have a valid subarray for which the AND is 0, right? So this is pretty cool. We can add other elements to it also, right? Cool. Now once we got that, what we can do is that we can just take another we can just consider the another subarray from the next part, and then we can just keep adding elements. And will it be beneficial if we don't if we increase the set? There is no point in increasing the length of this previous set, so just keep adding elements until this becomes 0, and if it not becomes 0, we will just add it to the last set. I think I've got it solution now, I am pretty sure. 5713. And can this case also be handled by this 0 1? Okay, no, this case cannot be handled by this. Cool. Okay, int current equal to nums of L. Okay, current equal to current and nums of R, right? Current equal to current and nums of R. If not of current, break. Right, if not of current, if current is there, right, then break. Otherwise what need to do is that if current is there predict, then in the other case L equal to R. Okay, R, L equal to R. So like I've considered up to R, then cool. Return answer plus plus. I think this is correct. Compilation error. Nums of L. Let's check this now. 3-1, right? This is working. Hope it gets accepted. Cool, accepted. Cool. This was a nice problem. Now let's come to the last problem, which is the hard problem. Cool. There is an undirected graph with n nodes labeled from 0 to n minus 1. You are given the integer n and 2D integer array edges of length n minus 1, where edges of I equal to ai, bi cool indicates that there is an edge between nodes ai and bi in that tree cool. You are also given a 0 indexed integer array values of length n, where values of I is the value of I not cool, and an integer k. A valid split of the array is obtained by removing any set of edges possibly empty from the tree, such that the resulting components all have values that are divisible. I think I'm over here. Such that the resulting components all have values that are divisible by k. For the value of a connected component is the sum of the values of its nodes. Achha. Cool. Can we solve it? It's an easy problem. People are solving it pretty fast. There's an undirected tree with n nodes. Cool. So we basically have a undirected tree here. 0 indexed values. Okay. Cool. And each node has some value. Apart from these values, we have an integer k. A valid split of the tree is obtained by removing any set of edges possibly empty from the tree, such that the resulting components all have values. Got it. So we can just do a DP here, something like that. Acha. No, not DP. So it's a good problem, I think. It's a DP on Teddy's problem only, I think. But let's look into it. What is the range of k? Sum of values is divisible by k. Got it. Okay, so like initially what I do is that we don't add any edge. So like okay, maximum number of components such that all are divisible by k in a tree. This is not DP on trees. Okay. Let's think about it. Don't look for solutions, just think. I'll just check my rank once. Call me Pandis is second rank, bro. Genius, bro. Like problem 2, I think, is not that much of a hard problem. Or like some well-known problem, I don't know. Under the tree, Acha, we can do something like this. K is insignificant here. Okay. So like, let's consider this. Like each one has to be divisible by k, right? Like initially the whole tree is divisible by k, so like the whole tree is a valid component, right? So initially the whole tree is a valid component. Got it, bro? Got it. Now what to do is that if we just remove any edge, right, can just remove any edge and it will just separate the tree into two groups. And if they are both mutually divisible, so like there is no point in keeping them attached, right? Or there is any point, there is no point. Like if we can break it, yep, there is no point, because yep, there is no point, just break it. So like I think it's a greedy approach can be done here. 1 2 3, like, so k is here 4, k is 6, right? So 3 4 5 6, okay, no, 6 to be divisible. Okay, k is 6, example 1, k is 6. 3 plus 1, values 1 plus, right, I got it. Values 1 plus values 3 is 0 1 2 3, cool. So 8 4, right? So like if we can break any component, just break it and just go to some, okay, okay, so like just initially consider the tree as here and just break it if you can break it. So like just okay. And is it possible that any breakage is bad, something like that? 0 2, right? 2 is 1, 4 is 0 1 2 3, 4 is 4, 2 is 1, 0 is 1, 1 is 8, 3 0 1 2 3, 3 is 4, right? Cool. So like if we just go to, so like here we get that I can just split this edge. Can I split this edge? I can split this edge. Can I split this? I cannot split this edge. So just split this edge. Yep, something like this is being done here. I think I've got it, but I'm not sure about it. I think I'm quite sure, but proof is not there. Vector of, okay, and n equals to edges dot size. Group edges dot size is length will be n minus 1, right? Okay. vector of int g of n, right? For vector of int, should I just do g, and also we'll do a parent array type thing. So we'll just keep on, okay, no need to keep the parent thing, so we'll just get handle in the recursion part. G of age 0 dot pushback age 1, g of age 1 dot pushback age 0. Got it? Cool. Now just do a recursion here, int answer equal to, okay, so like you have to first do a dp here, int dp of n dfs 0 minus 1 gdp void dfs int node int pa vector of int and g vector of int and dp for auto and child in g of node. Okay, and also like values you have to pass dp values vector of int and values, right? dp of node plus if child not equal to pa, dp of node plus equal to dp of child. Okay, so like the values I can be huge, right? So just you can just take mode, right? Just take k here, so that we don't have to do longs and all. dp of node plus dp of child percentage k, dp of node plus equal to dp of node equal to dp of node plus values of node percentage k, right? Cool. Now do another dp of dfs 0 minus 1 gdp. I think this one will be the my deciding factor. K int answer equal to okay int answer equal to 0, answer dfs 1. Okay, so like the answer is actually initially 1, and whenever we break it, it got time is going around. Void dfs 1 int node int pa vector of int and g vector of int and dp int k int and answer, right? Node pa gdp k answer. Cool, right? So now for auto and child in g, okay, firstly you have to do dfs child node gdp values k, child node gd values k, right? For auto child in g of node if child not equal to pa, right? Child not equal to pa if dp of node, right? cool. If dp of node, if dp of child, if not of dp of child, basically, right? Okay, if not of dp of child, answer plus plus. That's right. So I think it's that thing, it's just it. Compilation errors, right? Compilation errors. What is n here? Acha, cool. One three. Okay, so from the first case the answer is going to be 1. Right, cool. If not of dp of child, cool. Not of dp of child, cool. Okay, so like in the first case, so like in the first case 3 by 4 5 6, right? So this one should have come to be like this. Okay, it might happen that it's not coming. This here 5 6, right? So this one should have been there, right? Okay, got it. dp of child, answer plus plus, dfs 1. Okay, child node gdp k answer. Two, 3, right? This could have been done in the first go only, but let's do it. Cool, accepted, cool. Pretty easy problem, but I was not able to get it. Cool. Okay, what are the problems? What's my rank here in this contest? Let's check my rank here. Not a very good rank will be there, but okayish rank will be there. How will we solve the fourth problem? Under 500. Okayish rank. What can I do? It was an easy contest. Like I messed up both in C and D. Both C and D could have been done much faster. But rank will be around 543 only. Something like that. Cool. So that's it for this contest. Hope you enjoyed it. Let's go over a quick recap over the problems as my viewers suggested in my previous screencasts. Okay, so in this problem, okay, this one is a pretty easy problem. So like I think we would not go to in the problems A and B because they are pretty easy. Or may I go over B also? Okay, so like problem B is a little bit good. So like in problem B, I think you have read the problem. So like in problem B, you can remove equal elements in two ways. One way is that you choose any two of them and remove them, or you choose any three of them and remove them. So like since we can remove only equal elements, so just so initially form a map which contains the count of each of those elements. Now consider the case for each one of the elements separately. So like here in the first case, if the count of elements is divisible by 3, then in that case you can you can delete all of those elements by taking 3 elements at a time. Yep. So then in that case it's the best case. So in that case you can just add count by 3 to your answer. Cool. And now if the number of elements if the count of elements has remainder 2 on divided by 3. Cool. Then in that case there will be one extra operations, like you will do count by 3 operations in which you will form group of 3 elements, but in the last operation or in the last operation you will form a group in which you will take 2 elements and delete those. Yep, got it. Now comes the little bit difficult case. If the count of elements has a remainder 1 upon divisible by 3. Now if the count is 1, then in that case there is no way you can delete that element, because you can form groups of greater than equals to 2 elements. So in that case just return -1. Otherwise what you can do is that you can so like now the minimum possible number which has a remainder of 1 upon divided by 3 is 4, right, since 1 is gone. So like for the case 4, what we can do is that we can just do 2 operations in which we take 2 elements in each operation. So yep, and for the rest cases, like for the cases 7, 10, we will just do operations in which we will form groups of 3 elements. So like let me explain here a little bit. Let's say the number is 13. So like initially you did operation of -3 which led to 10, then again -3 which led to 7, then again -3 which led to 4. Now do -2 which led to 2, then -2 which led to 0. So like here the base case is actually 4. Like so every number you can reduce it to 4 by just subtracting groups of 3 elements from it, if that number has a remainder of 1 on divided by 3, and then when it becomes 4 you can just perform these 2 operations. So that's why what I did is that I just initially I keep aside those 4 elements and form groups of 3 elements on the remaining elements, and then just did 2 operations taking 2 elements each in each operations. I think this is clear from this example. Cool. Now coming to the third problem here. I think my rank is 543 only. Yep. Now let's come to the third problem here. Okay, so like third problem was also a little bit, you have to find it. Like if you can find it, it's a pretty easy problem. Otherwise you will waste some 3 to 4 minutes extra, like how I wasted here. Yep, lot of submissions here. Okay, so like in this problem, okay, so like I think the viewers must have read the problem at least, otherwise don't watch my video. Cool. So now okay, so like the now coming to the expression part. First of all, the if we take more and more elements, the AND or the bitwise AND of those elements will never increase. It will either remain same or just decrease, because yep, that's how AND works. No need to explain it in much detail. Yep, that's it. Okay, so like the what is it? So like the minimum possible score which you can get is that when we take all of the elements in a single subarray. Cool. So like the minimum possible sum of scores is the bitwise AND of the whole array. So that's what I did here. I just did the bitwise AND of all those elements, like of the whole array, right? Cool. Now coming to that part in which now what you have to do is that you need to split that array into small arrays such that the scores remain same. Now think about it. Let's say that the bitwise AND of the, let me explain here. Let's say that the bitwise AND of the whole array is 2, like any positive integer. Okay, so in that case what you can observe is that the set bits which are okay, let me put this in this way. The bits which are set in the bitwise AND, like in this case, in case of 2, the second bit counting from the left is counting from the right is set. So this bit will be set in each one of the elements of the array, right? So like for example, let's do it like 1 0 1 1 0, like 0 1 0 1 0 1 1 1 1 1 0 1 1 1, something like this. Okay, so like in this case, this second bit is set in all of the elements. That's why the bitwise AND is 2, I think. Yep, the bitwise AND will be okay. Let's copy it here only. Yep, so that's why the bitwise AND is 2. Okay, now if you split the array into like if you just split the array, what will happen is that this 2 will be counted 2 times, or like if you split the array x times, that 2 that particular set bit will be counted x times, because this bit is present in all the elements. So if you just split, it will be counted again. So that's not a good thing. So like if the so what we can observe is that if the bitwise AND is not 0, then splitting is a very bad choice. Like if we split, the answer will only increase. It will obviously increase, never decrease, or never remain same also. Okay, it might remain same. Yep, it might. No, I don't think it will remain same. I don't think it will remain same. It will just increase only. Cool. So in that case, don't split the array at all. Just take the whole array. So the answer is 1 only. So I just returned 1. Now if we can split the array, so in this case the bitwise AND of the whole subarray, so of the whole array is 0 only, right? Now what we can do is that we can just do a 2 pointer thing here. So just what I say, fix left element, let's say the first element of the array, and that is the 0th element, and continue adding elements to it until the bitwise AND of the whole sub array starting from the 0th element becomes 0, and it will obviously be 0 for at least one case, since the bitwise AND of the whole array is 0. Now let's say it ends in the 4th element, right? So like the bitwise AND of the elements from 0 to 4 is 0. Now there is no, so like now if we add more elements to this subarray only, let's say that if we add elements 5 6 7 and something like that, I am here talking about only indexes, not values, right? So like index 5, index 6, index 7. So that will never be beneficial. Okay, so no, yes, it will never be beneficial, since on adding since the bitwise AND is already 0, by adding more elements you cannot decrease the bitwise array. It has already reached its minimum value. So there is no point in moving beyond 4 for this particular subarray. So like in this case, you just took from 0 to 4 and then keep the right pointer from the element 5, and now keep on moving again until you find the bitwise AND to be 0, right? And just do on greedily continue this practice Okay, and let's say that the bitwise end of the last subarray is 0, then well and good, just add it, just so like it's well and good, that will be a separate subarray. And let's say the bitwise end of the last subarray is not 0, so like the bitwise end of the of this part is non-zero. Then what you can do is that you can just, you don't split this, you will just add this subarray to the previous subarray. Got it? So that's it. So that's what I did here. Okay, I just fix the left pointer and just keep on forwarding the right pointer, keeping the bitwise end of the current subarray in this variable named current. Okay, and if the current is 0, like the bitwise end of that subarray becomes 0, then I just stop moving forward. Now if, okay, so now if the bitwise end is non-zero, okay, and since this is non-zero, it means that our, like, we have reached the last element also, then in that case just add this subarray to the previous subarray, so like we will not be splitting again. So that's why we will just break here. Otherwise what we will do is that we will just add this subarray to our answer, so like answer plus plus, and just keep on keep the left pointer, start the left pointer again from the element r plus 1. So that's why I did l equals to r, and it will be incremented here l plus plus. So that's it, and just finally returned answer. Cool. Now coming to the last element, last problem. Think rank 543 is final rank, so I can just add it to my YouTube video. Not a great rank, yeah. I'm not practicing a lot. I'm not practicing at all, that's it. So maximum number of k divisible components, right? So I think again you must have read the problem. Okay, so like here you will be given an undirected tree in which you have to split the tree into small components such that the sum of the values of the nodes in those components is divisible by k. Cool. So like what you can do is that what you can observe is that here okay, so like so like if at any point of time you can remove any edge, there is no harm in removing that, it just remove it. Yep. So that's the whole point of this problem here. If at any moment you can remove any edge, just remove it, and just readily do this operation in a DFS manner. That's what I did. This whole thing can be done in one DFS only, but I messed up and did two separate DFSs. So that's it. Okay, so like this DP array will store the sum of values of the elements in the subtree of that node. I am maintaining the node 0 as the root, so like the subtree of the node 0 is the whole tree, the subtree of the node 2 is these nodes 2 6 5, the subtree of the node 1 is 1 4 3, and the subtree of the node 6 5 4 and 3 are those individual elements respectively, right? So like in a bottom up manner, what I did initially was that I did the DFS, and then I just calculated the sum of values of that subtree modulo k for each of the nodes. And for this it's a pretty easy DP on subtrees problem, so you can just look up on the internet if you don't know. So that's what I did. If I am at any node, first I will go to its child node and compute the subtree value of that child node recursively, and when I am done with that, I will compute the subtree value of my current node. That's what I did here, and obviously modulo k to avoid long int values. Okay, and then after that what you have to do is that if at any point of time in your DFS, if you can break this edge, like when you can break the, okay, so like another important thing is that you can always take the whole you can take the whole thing and add it to your answer, since it is given that the sum of values of all the nodes is divisible by k. Okay, so now let's say that how can you identify that you can break this edge? You can only break this edge if the subtree of the node 2 is divisible by k, because in that case this this subtree will automatically be divisible by k, otherwise the whole tree will never be divisible by k, right? So that's what I did. So like if at any point of time, if dp of child, this not means that it is divisible by k, since I initially computed the dp values modulo k. So if not of dp of child, then I will just assume that I break this edge and I will add it to my answer, and this will not harm the above part also. So like let me explain here. So okay, the examples are not good actually. Okay, the examples are, yep, not good at much. Okay, so it's good. So like consider this case. Let's say that I found that the dp value of the node 2 is 0, so I just break this node, right? So that will not affect the dp value of the node 0, right? Because the dp value of the node 0 is already 0. Yep. So like all the dp values will remain same. It is just that this whole subtree will be separated from the original tree, and then same with this subtree also. If we just remove this subtree and its value is 0, it will not harm the dp value of the parent node. So like let me frame this in this way. If the dp value of a child node is 0, so removing the subtree of that child node will not affect the dp values of any of the other nodes. Yep, that will not affect the dp values of any of the other nodes, since like, yep, that's what it is. Let's not explain it further. So that's it. So that's what I did, and just returned answer, and I passed your answer as passed by reference. Where it is, where did I pass answer? Okay, here passed answer. So that's it. This whole thing can be done in one DFS call only. I messed up here, but that's okay. Messing up happens, and I am not practicing at all, so it's bound to happen. Cool. So that's it for the video. Hope you liked my explanations, and this is, and from the request of my viewers in the comment section of my previous videos, I have uploaded the solutions also, brief solutions of course. So that's it. Thanks for watching this video. Bye.